There is a single sentence in the AQA mark scheme that is legally capping thousands of students at level 1. Here's exactly what it says. Answers with no title or a vague title cannot grow beyond a basic description and must be restricted to level 1. That is a legal ceiling on your grade. Today, we're going to destroy it. You've spent 2 years memorizing your case studies, but when you open the Seen Fieldwork section of Paper 3, the examiner isn't testing what you know, they're testing what you can prove. Right now, students are walking straight into a hidden mark trap that locks their 9 marker at level 1 before the examiner has even read your second line. Today, we're hacking the exact system AQA uses, so you can steal back every single mark. And that brings us to the box responsible for that exact rule, the Seen Fieldwork title box. Examiners from recent reports explicitly flag that a shocking number of students leave this completely blank, or just write one word like rivers or coasts. If you've ever done that, and I know some of you have, this next slide is going to sting. Here is the harsh reality from the official mark scheme. If your title is vague, the examiner cannot establish the geographical context of your study. And when you reach the 9 marker, evaluating your data collection or conclusions, the mark scheme is written so that a nameless answer is legally restricted to level 1. There is no way to climb out. The fix? Treat that title box as a credit-worthy question. Your title must hit 3 things: a specific named location, a clear geographical concept, and a measurable variable. Now we hit the final boss. Students have been handed this exact 9 marker. For one of your fieldwork inquiries, to what extent did the data collected help you to obtain accurate results and reach a valid conclusion? Most students fall apart on it. Before I show you why, pause for a second. What do you think the difference is between accurate results and a valid conclusion? They sound the same. They are not. And that confusion is exactly what AQA is counting on. To hit grade 9, you must build an explicit chain of inquiry, 3 separate links, and the examiner is checking for all 3. Link 1, accuracy, your tools and methods. Did you hold the flow meter correctly? Was your tape measure taut against the bank? Link 2, reliability, repeatability. Did you take enough samples? Would someone else following your method get the same result? Link 3, validity, the ultimate test. Did your results actually prove your original hypothesis, or did anomalies compromise the conclusion? Now let's see what a failing answer versus a grade 9 answer actually looks like. Read the next one carefully. Here is the kind of answer examiners saw en masse. Read it yourself first. Our river results were mostly accurate because we used a digital flow meter. Some of our results were weird because it rained, which made the water flow faster. So our conclusion isn't completely true. We could improve it by asking more people or taking more measurements. It feels okay on the surface, but examiners hammered it. 3 fatal errors in 3 sentences. Weird, not a geographical term, signals immediately that the student is working at level 1. Asking more people to improve a physical river study. That is a human geography method, total cross-contamination. It tells a story, it does not evaluate. There is 0 link between the error and the conclusion. 3 moves. Do all 3, in this order. Step 1, the decisive thesis. Don't sit on the fence. Open with a clear position. To what extent did your data achieve validity? The examiner needs to know your argument from line 1. Step 2, the equipment critique. Name a specific, concrete error in your data collection. Not just, it was raining. Name the instrument. Name the sampling interval. Name the exact technical problem. Step 3, the ripple effect. Prove explicitly how that specific equipment error rippled outward and compromised your final conclusion. This is the link that most students completely skip, and it is worth the most. To make step 3 completely foolproof under real exam pressure, look at this formula. Getting a grade 9 is all about showing a simple chain reaction. Think of your answer like a row of falling dominoes. If you knock the first one over, the rest will follow. It starts in your hands. You make an equipment error. That automatically knocks into the next domino, creating a mathematical data distortion. Because your numbers are now bent out of shape, they crash into the third domino, forcing a weird anomaly onto your scatter graph. And that single broken dot hits the final domino, leaving your entire hypothesis compromised. That is the ripple effect. Making a simple mistake with a flow meter or a tape measure at 9 a.m. physically ruins your data, which ultimately breaks the absolute truth of your final conclusion. If you don't trace your mistake step by step, from your hands, through your graph, and onto that final conclusion, the examiner legally has to cap your mark at level 1. Show them how the dominoes fall to unlock the top grades. Read this model answer carefully. Watch how every single sentence does a specific job. To a large extent, our data collection provided accurate results that allowed for a valid conclusion, despite localized anomalies. For our physical inquiry, we utilized a digital flow meter to record velocity. However, systematic sampling at 10-meter intervals meant we occasionally placed the impeller directly behind large boulders. This lack of localized equipment accuracy created an underestimation of velocity, appearing as an anomaly on our scatter graph. Which means that while our overall conclusion supported the Bradshaw model, its validity was partially compromised at Site 3. To improve this, stratified sampling should be deployed to avoid bed load disruptions and ensure repeatable, reliable data. One paragraph. Accuracy, anomalies, validity, and sampling strategy all linked. 3 SPAG marks collected in the process. That is a grade 9 structure. Full stop. Get your phones out. Screenshot this right now. Put it in your revision folder and look at it the morning of the exam. Screenshot this checklist. Write your full fieldwork title, location, concept, measurable variable. Never write weird. Use anomaly or outlier. Chain your argument. Accuracy, reliability, validity. Never mix human geography improvements into a physical fieldwork answer. State your thesis in sentence 1. Don't sit on the fence. Now you know the trap. Don't walk into it. If this breakdown just changed how you see paper 3, smash the like button and comment blueprint below. Video 2 drops next. The unfamiliar fieldwork traps that steal marks from students who think they're doing everything right. I'll see you there.